All righty. Hey, everyone. Thank you for joining us tonight. I'm CJ Taylor. I'm a senior solution architect at AWS. This is the Louisville AWS meetup group. We meet every month. I believe it's the second Tuesday of every month. That's kind of been our schedule. And so today, here we are again. What do we have going on next? I think we're having just a social for December, a social gathering as a group. And then I think we're still working on the calendar for 2024. Anything else to add there, Nick?
No, that's it. So nothing out on the meetup site yet. I think for December, I'll be figuring that out and posting it. And as soon as we get topics for next year, I'll be posting those too.
Awesome. Well, I see a lot of familiar faces. Gentleman back there. I'm going to be the guy at the restaurant, ask you if you need your drink refilled as soon as you take a bite. I'm CJ, by the way. I think I know everybody else here. I'm going to take a complete guess. Chad? No. No? What was your name?
Herb.
Herb. Well, I'm glad to have you with us here today, Herb. Thank you for letting me be okay, making a fool of myself there. I'm happy to do it. So we're going to have some fun together in this talk. I'm CJ, and today we're going to be talking about thinking serverless. So this session, it's about 30 minutes of content. I'm going to be kind of breezing through it. It's really casual. It's a 200 level topic. So we're not going to go into depth. My whole intent by this is the first of multiple parts of a series where we're going to try to take deeper dives into serverless and get more into it. So I'm glad you're here. Glad to see familiar faces with us. But with this, we're going to be going from business problems to serverless solutions. I'm a senior solutions architect at AWS. I specialize in training and certification. I've been an engineer, a builder, a developer, an architect, and an internet plumber. So I've kind of done all of the above, and I love talking serverless because there's less of that. But in order for us to, hey buddy. In order for us to dive deeper into this, we're going to start back where we came from, servers, and what the world was like with those involved and what to expect there. That's going to set the scene because we're talking about how that's influenced our architectures and how that transitions into our different line of thought that we need to take with serverless solutions. From there, we're going to talk about good design practices for serverless architectures. That's going to give us a good springboard into our three business problems that we're going to see today. We're going to walk through three real business problems and layer on customer requirements and see how that influences an architecture and allow us to practice thinking serverlessly. Along the way, we'll make some pit stops and talk about what that could have been like in a world of servers. Again, this is about 30 minutes of content. We'll have a lot of extra time at the end for open Q&A, so I welcome you to join me there for questions. So how do we use servers? Many of us in this room may or may not have been part of developing solutions when a server was present, and you may still actively be doing that. From systems on premises to EC2 instances to maybe even orchestrated services like Elastic Beanstalk. Servers are a good way for you to be able to run common tasks for your workloads. But as we design our systems and our applications on those servers, we find ourselves building monolithic containers for functionality. We start grouping functionality together. You end up seeing the monolith to microservices, all of those phases, and you're just kind of grouping similar functionality together. And as you do that, you find yourself with multiple versions of your application. And it kind of boils down to one version for one server. And to roll out another version, you start looking for different deployment patterns, like introducing new servers to run that other version simultaneously. And so we find ourselves with this atomic unit of thinking, the server. Meanwhile, we're trying to address the customer problem with a business application. And we're also managing all of this other infrastructure as the server. There are challenges with this model, scaling, state management, you name it. So to run a production system with a moderate amount of traffic with servers involved, you may need something like this. This is a reference architecture for WordPress. I picked this because WordPress still has a considerable foothold within websites on the open internet. But this really could be any LAMP style application, Linux, Apache, MySQL, and PHP. Could even be a Java application as well. But the takeaway here is the traffic flow. We go from the customer up there to a load balancer to a WordPress instance, an EC2 instance, that's then making requests to a relational database. And this relational database is allowing us to load things like themes, plugins, other components of WordPress to just build a static website, a largely static website. There are some dynamic capabilities there, but this is largely static. And that ends up going all the way back to the customer and rendering in their browser. So you might say this is a lot of work for a largely static website. And you'd be right. Most that are new to serverless will be like, well, you're just going to replace that WordPress instance. You're still going to have all of that other stuff. That's not it. That's the starting point for part of it. But in a production workload like this, you end up having all of these other interconnected parts to manage for your production workload. Around each parts of your workload, you might have security groups to limit the amount of access. You might have subnets configured in each availability zone, all the way to auto-scaling policies and groups around different parts of the workload and load balancers. So you find yourself holding together all of these moving pieces for a seemingly static website. Now, this isn't the worst. This isn't bad. Sometimes it makes sense for your organization. But the goal of serverless in this situation is to eliminate a lot of that operational overhead and allow you to focus your limited development time on solving your customer problems. So where do we start? Well, with serverless, it's exactly as I said. We're trying to reduce the operational overhead. You get to focus more of your time on building your solutions. To do that, we'll walk through some tenets, some guiding principles of thought for us to walk through this exercise. Now, I mentioned we're going to go through 3 business problems, and we're going to see these kind of tenets in practice, starting with features first. As you're working on your business problem, that last one, we were talking about a static website. We'll see an example of how that can be done in a serverless design here in just a moment. But start with your features first. Decompose that into the simplest bits of functionality that you need to achieve, and then try to address that with managed services. This also avoids something that I'm calling monolithic thinking. If you just try to take that full business problem and shove it straight into one solution, it's going to have a lot of reasons to change, a lot of reasons to fail. And so you end up getting into what you'll find in software design, big ball of mud, all of those kind of lift and shift kind of fallout scenarios. Next, focus on events. Events here can be anything like an HTTP request, a scheduled event inside of EventBridge, or an upload event to S3. Events are key to serverless. They help initiate the workflow occurring. There's a rich ecosystem inside of AWS of various events that you can key off of to piece together your serverless workloads. We'll see that in action. Stateless tends to be a hard one to conceptualize for those that come from a server-based background. What happens to state whenever the server has gone away? Things like user sessions, state tracking of what is or is not in a shopping cart, for example. As we look in some of these examples, we'll find where state is not present in a lot of the moving pieces because we're triggering the workflow off of events that push that through. We won't get into too much of those details in this talk in today's session, but future sessions we'll talk about enrichment pipelines for serverless workloads. Data flow. Think about your data as part of your features and of your solution and what type of data it is. Are we looking at videos, images, text content? Does it need to be stored in a relational or non-relational form? AWS has a very broad ecosystem of data offerings to fit all of those needs. And we'll see that in action in these examples. And think about the serverless services first. There's no good in reinventing the wheel unless you need to. We can often find ourselves reaching for that, thinking that our use case is particular, special, but where all possible, reach for the serverless services so that you can focus on delighting your customer, solving their problem, and not taking on a lot of additional operational overhead. So serverless services, I've probably said that about 30 times already in this session. I'm not sure who's keeping tally or who has an over and under bet on that one. Let me know what those numbers are, and I'll make sure to see who one of you win in the situation. But when we talk serverless, most people will jump to, well, that's Lambda. It's a synonym for serverless. Well, Lambda isn't it. It is part of it. Lambda is a function as a service, a just-in-time compute for you to run your code in reaction to events. But that compute needs to be accessed by things like websites or a web form. How do we get it there? We use something like API Gateway. API Gateway gives you those endpoints. And then maybe we need to store data, text data, in a web scale, low latency database. Let's pick something like DynamoDB. It's a NoSQL web scale, NoSQL database. And if we have image or video content, you might look for Amazon S3. S3 buckets, it's for big object storage, and you can do a lot with it. But say your workflow isn't as simple as piecing together these solutions, and you need to orchestrate it and have it do various things. Maybe do some error handling, retries, and so on, and orchestrate multiple of these together. You would look at AWS step functions. That allows you to declare that workflow and piece all of these together with API integrations and service integrations. So with all of this, I mentioned that events are key to a serverless architecture. In the application integration category, there are things like Amazon Event Bridge, Simple Notification Service, and Simple Queue Service. Event Bridge will allow you to key off of those events, create your own custom events, and route them appropriately. Simple Notification Service, SNS, will allow you to decouple some of your workloads or even send internal emails based off of that workload. And then Simple Queue Service, plugging that in allows you to create a durable storage of work to be done by your workload and kind of gives you an illusion of infinite scalability for your workload. You store it and then process later. But you might find specialized use cases for your workload. Maybe you need to stream live content or perform analytics on it. You might look for Amazon Kinesis. Say you need to integrate something from an on-premise location, like in a storefront, a button, to integrate into this serverless design. You might look for AWS IoT Core. And then if you're processing large media files, you might look for something like Elastic Transcoder. We're going to see a lot of these in our example today. Lambda integrates with a lot of other AWS services. So the takeaway from this one, I'm not here to overwhelm you with a bunch of icons. You don't need to memorize this slide. That's not the point. The point here is that something like Lambda can integrate with categories of services like machine learning, Internet of Things, analytics, media, web, mobile, and digital. There's a lot of underlying services that you as a serverless developer in AWS can piece together to solve your problems. Mix and match them. And the other big takeaway for this is these are all pay-as-you-go services. You don't need to make a big upfront commitment to use any of this. So as you're thinking about your problems that you're solving and breaking it down, you can start piecing those scenarios to the applicable service. Now, as you're building your solutions, it's never a bad idea to think about best practices and not have to recreate the wheel, not have to relearn issues the hard way. Others have gone before you, and it's never a bad idea to look at what is out there in terms of best practices. Thinking about where Lambda is inside of a serverless workload isn't a bad place to start, but I'll counter that here in just a moment. Let's first understand what Lambda is and does from its attributes. Who here has, built a Lambda function before or is familiar? Okay, so we're kind of splitting the room a little bit. So Lambda runs on demand. It's ephemeral compute just in time. It supports many different runtimes. There's default runtimes. That's what your code is developed in. And then you can use different languages for those runtimes. Can be for Python, Node.js, Java, .NET, and a few others. But if you find yourself not being able to use any of those runtimes, maybe you've got a scenario that you need to implement a custom runtime. Maybe you have PHP or Erlang or COBOL, that you need to run inside of a Lambda function. You can do it. You can do it. It gets fun. But that Lambda function that's running in those supported runtimes or custom runtimes responds to events, back to events being a key for serverless workloads. Those events, again, could be an HTTP call, a scheduled call from something like EventBridge, or an upload to S3 initiating a workflow. There's many other options there. But as your Lambda function is running, it's ephemeral and stateless. It runs for the duration of your workload. It can span from 0 seconds all the way up to 15 minutes. But it's stateless. It doesn't know what happened before or after. You can implement state inside of your system, but watch out for that. We'll talk about that in a moment. And as you're running your code inside of Lambda, it automatically scales on your behalf. You can tune some pieces there to control that for your type of workload, but you ultimately are writing your business logic, giving that to Lambda. You don't have to worry about some of the major scaling concerns that come with scaling in response to customer traffic. So deriving from these attributes, we can look at some best practices that have been observed. Avoid the lift and shift. It is really tempting. I've seen it, I've done it, I've been there. Say you got a Java application that's running just fine on a web server and you want to shove that into a Lambda and call it a day. Can you do it? Yes, you can. Should you do it? Maybe not. Watch out. It could be alluring to start with some of the types of things like that. But again, take your business problem, break it down, and consider rethinking and doing a leapfrog of some of those pain points of just trying to lift and shift that type of workload into Lambda. Lambda is not, to the end customer, seen as just a bunch of servers. It's ephemeral compute. And so while you can do some of those things, you're going to realize you need to probably rethink your workload a little bit. It goes into one function per purpose. Now, if you were to shove a web server inside of Lambda, what's it doing? More than one thing. It's resolving requests, it's got a controller, it's got models, all sorts of things inside of it. It's doing data access, you name it. It has a lot inside of there. It becomes your ephemeral monolith. Not a great idea. One function per purpose. That gives you one reason to change and one reason for it to potentially not work. Those who here has got a software engineering or development background? Yeah. So you might be familiar with the single responsibility principle, or maybe even the Unix philosophy. Do one thing well, have one reason to change or one reason to fail. But as we define our one function per purpose, we should keep our functions small. It's common that a Lambda function may be 20 to 50 lines of code and complete all of its work in a few hundred milliseconds. And as you're designing your Lambda functions and decomposing your workload, choose the right runtime for the job. I mentioned default or supported runtimes and custom runtimes, but you might choose a runtime like Python for data-intensive workloads inside of Lambda, Node.js for managing JSON, and maybe your team is familiar with Java, so you want to run with Java in a particular area. You can do that. And inside of your function, try to think about focusing on only the business logic. Business logic and plumbing. It's a good idea to think of Lambda and data as transformed, don't transport data within a Lambda function as a good rule of thumb to avoid violating some of those other better practices. But the good practices don't stop with Lambda. We find those in serverless, such as the infrastructure being disposable. You don't have servers, and you're declaring your code to create your infrastructure of your serverless workload. Spin it up, tear it down as you need to for your workload. That's really up to you and your application. Favor asynchronous versus synchronous processing. This gives you the appearance of infinite scalability for your workloads. If you achieve this, you can store first, process later. And that's a good way to go about avoiding a lot of the scaling concerns or congestion points or hot pads inside of your workload. With your runtimes, you can mix and match those. I already mentioned you can have Python, Node.js, and Java, but in a serverless application, you're likely to see a number of Lambda functions, and they may or may not all have the same runtime, and that's okay. If you have different areas, think of in the microservices approach, each one may be implemented in their own language, and they may all be decoupled by REST or a service bus. You can do a lot of the same, if not more, in Lambda and choose your own runtimes. The security is still very important. For this, I highly encourage you to check out things like IAM and how to scope your execution roles for your Lambda functions. You can use things like IAM Access Analyzer to analyze actual traffic over time and fine tune that and try to tighten it down to what it needs to. I like to make the analogy of you can put something on a trailer, you can try to haul it, but sometimes you got to go back there and ratchet things down and keep it from falling off. That's a good practice in this case too. Make sure you don't have too much access or over provisioned access. And IAM Access Analyzer is a good way to do that. And then automation. It's your friend. Look for things like AWS CDK or the SAM serverless application model or the serverless framework. These are all ways for you to declare reusable components for your serverless workloads, for you to achieve disposable infrastructure and define all of these good practices inside of your workload. So we've got through a lot of the content already. Now we're going to go into our actual examples. Like real problems in the world, there are many solutions. I'm going to put on the screen some business problems. We've got 3 to walk through, and we're going to talk about customer requirements, internal and external customer requirements, kind of like user stories. And we'll see how that manifests in a serverless architecture and kind of talk about that. We'll make some pit stops to talk about how that could look like, compare and contrast inside of a serverless workload. And so with our first scenario, the form upload. Who here has written an HTML form and uploaded some content somewhere before? Any takers on that one? It's tried and true, butter on a biscuit kind of situation. But here we're going to do that in a serverless fashion so that we're going to have a customer review form. We're going to accept text content from a website. Now, we're going to make some assumptions in this one. We're going to assume that the website is already HTML. There's already a form. There's already a button. I'm sorry, I took out the cool parts, but we have this form that needs to call a serverless endpoint on our behalf to store the content. So here we go. DynamoDB, we're going to introduce that table, managed service, web scale, NoSQL. We'll store the content inside of there. Okay, how can we get the reviews in there? Now we've created our database. Well, API gateway. We can create a public endpoint. Our web form via JavaScript can make web requests to that API gateway. All right. Well, how do we get that web request to the DynamoDB table? In this case, I'm going to choose to use AWS Lambda here. It's going to take the body or the parameters of that request, translate that into a new item created into the table. That's it. In a web-based environment, it wouldn't, in a server-based environment, it may not have been much different than this, but you still would have been managing servers. You might have configured an application, a new controller endpoint, maybe a reverse proxy to route to a different endpoint, maybe a new table on your relational database. Could have looked very similar, but you would have been managing a lot of the additional plumbing below your application. So this is it. That's all that it would have taken to achieve that. So let's go to our first new requirement. Let's talk about taking those incoming responses and let's translate them to English. So let's assume that we're providing this to a global audience. They're not all providing us reviews in English. Maybe we're accepting them in Spanish, Portuguese, Chinese, and so on. And we need to translate them all into English. Sorry. Can we move that somehow? Oh, no. Is that on your screen?
Yep.
Oh. Cool. We're gonna have a lot of those down the corner. I didn't want you to miss out on our awesome user stories down there. Thank you. So we need to translate these requests. How can we do that? We've got two options here. One, we could change this first Lambda function to store and make the request to translate. But what are we doing there? We're trending towards the monolithic. We're violating that single responsibility principle, and we have a function doing more than one thing. And we're suddenly giving this working workflow another reason to fail. Well, how can we change this design to avoid all of those impact points? We could take the store first, process later approach. This is a good practice to be able to help your systems absorb failure modes by decoupling. So we'll have those input coming through, stored in the DynamoDB table. We can configure a stream off of that DynamoDB table. That stream is an event stream that can then invoke a Lambda function. All of these are managed services. This amount of code here would just make the call to translate it, and then save it back into the DynamoDB table. So we did all of this without impacting our critical path of taking in the reviews. Now, as a back office operation, we can translate them to English. So what about our next user requirement? Our users love sending us reviews in text. And suddenly they're like, we want to give you an image and show you the good parts of your product, or maybe not the great parts of your product. So we need to be able to allow them to upload an image with their text response. All right. Do we want to update this Lambda function? Yay, nay? Well, if we updated that one, we could store the image. Well, I mean, we could try to put that inside of DynamoDB. 400 kilobyte limit, that's for text. That's not where an image goes. Well, we could try to do it on this Lambda function too, make it translate and store an image, but that's after we've received the text. So that's not a great idea either. So let's maybe consider adding another route on our API gateway. This goes back to thinking about where your data and what your data is and designing your workload accordingly. So here, we can put a new route on our API gateway to invoke a new Lambda function. Now this looks a little weird. We've got the client going directly S3 and some back and forth here. That's by design. That route from the API gateway is initiating a Lambda function. That Lambda function's sole job, create a URL. It's a pre-signed URL for us to return to the web client so that the web client can upload the data directly to S3. So that seems a bit odd, probably on the surface, but what did we just avoid by doing that? We don't have to send an image through API gateway, through a Lambda. We don't have to configure any sort of storage concerns there. We don't have to scale a workload. And imagine doing that in a server-based world where you would have to have that amount of ephemeral compute to support taking in all of those images, storing them somewhere, and then temporarily, and then uploading them somewhere else permanently. So we avoided that by allowing direct authorized and authenticated and authorized access to upload it to S3 by giving it that just-in-time upload URL. So let's talk about our next requirement. Well, we have a manager that says, I've seen a lot of negative reviews. I'm tired of going and refreshing and looking for them and trying to find the piece of hay in the needle stack. You know, let me notify me about those. So maybe in a web server-based world, we would have to implement our own sentiment analysis. That can be complicated. Well, where are our changes that we can make here? At what point do we have the content to detect that? Well, we take in the reviews at this point, we store them here, so that's probably a good point. We could update that Lambda function to translate and to request the sentiment analysis and then notify off of that. But again, this is that opportunity for us to avoid updating any of the other parts of the application and instead leave it open for extension for this isolated part of the workload. So here we can have the stream from DynamoDB invoke a small Lambda function to make the call to comprehend to detect the sentiment, positive, negative. If negative, send a notification to an SNS topic where your manager could be subscribed to that, and you've automated that problem away. Well, we've done it. We've got this long chain of events. We take in the reviews, text and image, we translate them and we detect sentiment. But this has been something that's all the users can do, authenticated and unauthenticated. So in a server-based world, to make this have a requirement for authentication, we had to put all of this behind something like session-based authentication. The whole server would have to, block all, route all of the traffic accordingly to those endpoints. But here, we can avoid having to update everything by having authentication and authorization happen off the API gateway. We offload that. We introduce something like Amazon Cognito, another managed service, has a very considerable free tier, 50,000 monthly active users, free. So why not? So here we go. We can set up Cognito. It has a deep integration with other AWS services, including API Gateway. We kind of use it like a guard. Any requests that go from an unauthenticated user without a header on it to the API Gateway, you actually wouldn't get billed for in that scenario for the unauthenticated requests. So bolt that on there. And then once that's authenticated and authorized, we pass all of that information to the downstream systems. In this case, the only parts that really care are these two Lambda functions, and they would only invoke based off of the access that you configured for that type of user. So there we have it. We've got our full solution, all serverless, a chain of events to achieve our outcome. Any questions on this one before we proceed to our next business problem? I see some head nods, some smiles. I think Q&A is going to be a lot of fun. Our next one, we've only got 2 more business problems, a wrap up and a few surveys. We're going to create a virtual queue. We've got a global retailer. They want to implement a virtual queue. They want to use an IoT button. They want to press it and say, now serving customer number 4, number 12, and so on. So we've got 2 applications really in this. We've got the button and we've got the display. In the button scenario, we have that IoT button here in the physical locations. It initiates a publish to an IoT core that invokes a workflow from a Lambda function to increment a counter in the DynamoDB table. That's it. I could have a button right here that does that. And we could be, playing smash the button. Who's the strong man? Who could get that number the highest in, I don't know, 20 seconds or something? Put that on a drum pad. Best drum roll is 51 beats. That'd be some fun. But then we got the second application here, the customer display. Customer display is polling an API gateway endpoint to do the similar pattern that we saw in the last one. It's making a Lambda request to a DynamoDB table to get that counter and then display it. Now, this is a global retailer, and I mentioned one of the bad words, polling. Is that efficient? No. In many cases, polling will get you the same response. So this is going to be infrequent data changes. So that polling scenario leads to our first customer requirement. They want a real-time display showing the current count. So how can we achieve this using our serverless mindset? We could update this Lambda function or that Lambda function. We could change this a number of ways. But we're actually going to shift it up a little bit. If we were to update this Lambda function, we could have it store first in the DynamoDB table. It could also call IoT core. This IoT core could then make the necessary updates to the customer display in the global retail location. But let's still take that a step further and do the store first, process later approach. We can store in our table, use the same pattern as we said earlier, a stream invoking a Lambda function to publish the necessary message to IoT core. No major surprises there. You saw this pattern in the first example, but that's just the versatility of these patterns. So we've solved the problem of having the button update a number on a screen in global locations. But they found that their customer service people on site were getting tired of speaking that number out, saying now serving number 4. And they're a global retailer. And so they want the system to now speak that. What would we do? We've got the text, we've got the number, we've got a mechanism for getting those updates out there. In this scenario, we can kind of modify this dynamic right here, the Lambda, the stream to the function, publishing the message up to the display, and expand that workload a little bit. Kind of remove that part and replace it with this, move those down there. So this Lambda function off of the button increment counter would invoke Amazon Polly. Polly would take text and turn that into speech and also make that into different languages. We can generate all of those media files, put them into an S3 bucket. The S3 bucket can have an event notification that initiates the Lambda function. No surprises there. We've done that one a bit. That function then would send it out the door to the customer update display. So there we have it. We now have it to where all of our global retailers can hit a button, see a number change, and off the intercom system now serving numero ocho. But now we've got an internal customer requirement. A manager now inevitably wants a report. They want to know how many times was that button pressed? How many people did we potentially serve? And I want to email to me. Convenient, right? Anybody been in that situation? Get those requests for those reports. It never happens, right? So what can we do here? This is effectively a daily cron job. In a server-based world, we would put a cron on a system. But how can we do that here? Well, we could use Amazon Event Bridge. We could use a scheduled rule expression or Amazon Event Bridge scheduler. You define on a daily basis here to invoke a Lambda function to do some of what we did earlier. We'll query the DynamoDB table for that history of the count and publish that to an SMS topic where whoever needs to be can be subscribed and receive that email notification. So we've had a few different patterns emerge, and we've seen it implemented now in multiple scenarios of solving customer requirements. All right, a new scenario. We need to publish this current count to a mobile app. Customers were not as happy to show up and see that their number had already passed, or they hopped out of line to go, get food next door and then come back. So they now want to see it on their app. They want a mobile application to see that number. When should I show up to be in line at the DMV? Well, we already have all the parts for that. We don't actually need to change our architecture. We have the storage first, the process later, the real-time update to a customer display. We can effectively reuse that and implement just a website that's using something like the Amplify framework to integrate with these existing pieces of infrastructure. Problem solved. We didn't have to change our background infrastructure to achieve that customer requirement. So, psych, sorry to fake you out on that one. No changes here. That's kind of like answer D. No, none of these apply, right? So that brings us to our third business problem. We need a serverless web app, and we're going to support a national e-commerce business. So e-commerce, national, it's going to be spiky, unpredictable traffic, geographically distributed customers, and we need a high-performance front-end application since it's an e-commerce use case. So that leads us to our first requirement. Fast performance for visitors in multiple regions. If you were in the United States, many different AWS regions geographically over the US, and I'm not sure that we'd want somebody in California having to send their traffic all the way to Virginia to load the site. Instead, we could probably route them closer to them. So this is a static website, e-commerce, a lot of static content, little bits of dynamic content in there from time to time. So let's focus on the static aspect. Any front-end developers in here? You probably build with React.js, Vue.js, or I don't know, are you an Angular fan by chance? A long time ago. It's making a resurgence though. They just had some big updates. You might want to check on that. They had some big mic drop moments this past week. But so you're going to build a static application, and you need to be able to push that out to your users. And they're geographically distributed. So your static frameworks, your front-end frameworks, you're effectively building your application to compile it down to HTML, CSS, and JavaScript. And you need to serve that static content out there for them to rapidly access across the, your geographic area. So you could do that. You could build it. You could publish that content to an S3 bucket. That bucket, you pay for the storage and the request to it. Well, you could put CloudFront. Amazon CloudFront is a content delivery network, a CDN, and it's globally distributed, over 200 points of presence. So by doing that, you suddenly open up the possibilities of shipping that app to all of your customers really quick from all of those points of presence. But we can take it a step further. You know, in that scenario, you had to create the bucket, you had to manage your own build process, you had to configure CloudFront and manage all of those pieces. Back to that guiding principle earlier, think about the managed or the serverless services first. This is an opportunity to look at something like AWS Amplify console. Anybody here using Git in their day-to-day work? You know, your write code, git commit, git push. Well, in that scenario, Amplify console integrates with your preferred Git providers, and on push, you can configure it to automatically do your CI/CD pipeline, your continuous integration and continuous deployment pipeline. It could build it and publish it out to all your users. And behind the scenes, it's managing that S3 and CloudFront configuration for you. So you don't need to worry about some of those nuances, leaning more into those managed services and serverless. So we've got our static application. We decided to go with Amplify console. We're using GitHub here to push and deploy that out there. And we've met our requirement of pushing it out to content delivery network and being globally accessible really quick. Now, we want to allow our users to create their accounts without creating a new account with us. Instead, log in with your social provider. What can we do there? Imagine implementing this in your own system and your own servers. That'd be interesting, to say the least. We can go back to our friend Amazon Cognito with his nice, nice free tier offering of 50,000 monthly active users. That would allow you to integrate with all of the AWS services, like I said, but let's imagine, for instance, you already have a third-party authentication and authorization provider. Let's assume Auth0 as an example. Well, you can still use that. You can integrate that with Cognito. You can put a custom authorizer in place. If we were using API gateway here, like we were in the previous examples, those custom authorizers still allow you to use Cognito and that whole mechanism to authenticate with your authentication providers, get that custom JSON web token back, and be able to use that for your authentication and authorization schemes for your downstream systems. So now we're able to allow them to use social login. Cognito allows that out of the box, but here we'll move past that and go to our next business requirement. We need to support uploading and serving user videos. Well, in a server-based world, videos, they're large. They can be very large. And we go back to that storage provisioning problem with our images from earlier. You'd be having to manage a lot of ephemeral space, store it, process it, and then send that along to its permanent home. But in a serverless world, we can implement our similar pattern that we saw earlier. We can have that web client make a call to API gateway to get us that S3 upload URL, and then return that back to the client to be able to upload it directly to S3. We've again sidestepped that whole scaling concern of needing to scale storage and have our compute process binary objects that really have no right of going through that compute layer. But that meets only half of our requirements. We have allowed them to upload the content. What about serving the content? Well, to serve the content, we need to make sure it's fit for distribution for all of our different users. So we might need to convert it. In that scenario, we can key off of the Amazon S3 event for the put objects there and use event notifications to initiate another workflow. In this case, we can lean on Lambda to initiate a workflow to elemental media convert, to convert those video files to the appropriate resolution and so on, store them into another bucket and say that they're processed. Well, that processing upload can initiate another Lambda function to take inventory, to go collect the metadata for those videos, where they're at, their dimensions, their codecs, all of those details, store those in the DynamoDB table for use in our active application and other applications. So we've created that inventory catalog of all of those large video assets. So all of this is done, and we haven't provisioned a single server. All of these services are pay for what you use. The pricing can all be calculated. You just have to put some estimates out there of the volume of your workload, the size of your compute, the duration of how long they might last, the amount of monthly active users. You can do all of that, kind of your back of the napkin math in the AWS calculator, and come up with an idea of how much something like this might bill you over time. But frankly, in most of my use cases, the free tier gets me by quite a bit. So let's circle back around. We've gone through the examples, and we've leaned on our tenants for designing our serverless solutions. We focused on our features first so that we would avoid allowing parts of the workload to do more than one thing. And this allowed us to create a composable system that was able to absorb shifting customer requirements. We didn't have to have a change here, manifest, and show up in other parts of the system. If you've been in large system updates or shifts in requirements where you think adding a label here suddenly equals 12 changes across systems way over here, you've got a lot of tight coupling. So we intentionally took a decoupled approach in our serverless design to avoid the monolithic thinking. We focused all on events. We had uploads to S3. We had changes to a DynamoDB table, taking a store first, process later approach, so that then our serverless workflows could do what they needed to. Events are a large key to serverless systems. And then we were stateless. Notice the Lambda functions in each one of those scenarios. They weren't making calls back to stuff to see what happened before or after. They were operating off of a stream or an event. We might have stored it first and made the event propagate to it later, but we were avoiding maintaining state, allowing us to scale effectively. And then as we saw shifting requirements, we identified the type of data that we were operating off of and the flow of it. We were able to make data decisions early and often in our process to guide our selection from the tools available in our developer toolkit. And then we favored the serverless services first. We didn't reinvent the wheel. We went for managed services, and all of that we put together there would have solved our customer requirements without provisioning a single server. So what's next? What do you do? Now that we've talked serverless, we talked about thinking serverless, how can you take the next step? I highly recommend checking out the knowledge badge readiness path on AWS Skill Builder. AWS Skill Builder, managed learning platform that AWS offers. There's a lot of content on there for free. You do not need a subscription to access this. You can sign in with your own account and work towards achieving a technology badge for the serverless category. This is about 13 hours of content. And inside of this, you might see some of what we talked about. It'll lead you through designing event-driven architectures. We'll be talking about designing, deploying, and scaling serverless architectures. Lambda is not the only focus of that workshop, of that content. So you can scan the QR code there. That'll take you to the public path to be able to start this knowledge badge. Anybody seen this before or checked out this pathway yet or have achieved it? You got it, Andres?
I have it, yeah.
Yeah? Do you remember good or bad things about it? How'd it go?
I think it was good. I mean, that's really all I try to mess with AWS.
Yeah.
The application that I've built is probably has most all of the services you listed except for the Internet of Things.
Yeah.
And some of the voice recognition stuff.
Yeah.
Also dabbled with some blue stuff, some data analytics stuff. That,
Yep.
Probably is a good setup for a scenario 4 type of thing. There's some serverless.
Nice.
Data analysis.
Well, excellent. Yeah, there's a lot that you can do with it. So I'm glad that you were able to check that out. So I highly recommend scanning this. I'll send a link inside of the meetup group as well to this one. It's not any sort of special link or anything. And then now for me, this will allow you to grade my work. If you don't mind scanning this code, It'll take you just a moment to fill out the survey. Let me know how I did. I have a question on there, intentionally asking what types of sessions in the serverless space you would like to see, because this was intentionally a 200 level. Now, I know Andreas and a number of you are highly versed in AWS and particularly in serverless. So this might have been a lot of the same. We're going to continue diving deeper, but I wanted to have the whole group join us on the conversation. So feel free to let me know if there are specifics. If you want to see serverless blended with AI and L, serverless with data analytics, or how to do Internet of Things with serverless. So feel free to put those details inside there.
CJ, how is availability, redundancy, resilience, how is that addressed in a serverless environment?
Yeah, so I apologize. What was your name? Yeah.
Bill.
Bill. Bill Dustin.
AWS.
Okay, I apologize. I recognize the face. I just couldn't recall the name. Sorry, Bill.
Sure.
Yeah. So reliability, resiliency, and redundancy, that was your question, and high availability. Well, with Lambda, with API Gateway, they're all managed services and they operate within a region. And so if you do need to say have a multi-region workload, you can handle it at the DNS layer. You could have your workload go to different independent workloads that work within a specific region. And then that goes back to using infrastructure as code, CDK, your chosen infrastructure as code to declare your workload. And then you can deploy that out to those different regions and have them operate independently. So that makes your blast radius of failure modes to that region, to an availability zone, and so on. So you can get more granular with that, but in general, that would be kind of a really good strategy. Now, in terms of resiliency on a regional level, we took a store first, process later approach intentionally. You could do a lot of what we just talked about, go straight from the API gateway, the web request, and immediately, maybe do a service integration for any service. Let's imagine, for instance, that Comprehend and API gateway can talk directly together. That might take some time in between there. And so what you can find in those situations is that the request from the web times out before the work gets done. And then the customer basically has a hang up and is like, where'd my answer go? I didn't get a response. There are timeouts there. But that's why we intentionally take the store first, process later approach. We'll take the Hollywood principle, don't call us, we'll call you, store it, we'll process it, and we'll send you the update. So we put some real-time things in there to avoid some of those innate issues from trying to wait for the full workload to get done before you get a response. Bill, did that address most of your question?
Thank you.
Amplify has an example of that is Amplify. Like they have a 30-second timeout for the request. So if you don't get that response back in 30 seconds, it will just time out.
Yeah.
It could be 31 seconds when you're done processing that request. But
did you run into that?
yeah, I had. Then I was like, man, what am I doing wrong? So then I kind of troubleshooted some of the errors, and I figured out that was kind of like a set thing that it's not back in 30 seconds. Figure out another way of doing it or something. So
how did you choose to go a different way? Do you recall what you did there?
I had to refactor my function to make it respond faster. I was doing a query on a diamond table, and I was kind of going through the data, some of the data that I didn't need to go through. So it just took a little longer to get it to where it was responding faster. But so it's still using a Lambda and within the 30 seconds now.
Yeah, excellent. So sounds like you kind of leaned in, tried to make that Lambda function do one thing well, and maybe optimize its runtime for the job.
Yeah.
Yeah. In a lot of those cases, imagine, did you have a lot of items that it was probably pulling back, doing a batch get?
This particular one was going through all shipments of last week and picking out just for validation, the shipment of each of the type boxes that we ship.
Yeah.
So the end result at the end, what I ended up doing is as soon as it found one, it would stop looking. And because there's a lot of data in the partitions of a diamond table, it would loop through the partitions. It was doing some extra loops for the last one. So I mean, I just had to put some logs so that I can see where it's taking the most of the time. Got to figure it out.
Wow, that's really cool. Yeah, another opportunity. It sounds like it might apply there,
Mhm.
but pagination could have been your friend there to work on some of the pages at a time. Or, submit, take that storage first approach. You could say, I need to run this report. I'm going to submit that request and then have that
Yeah.
other system not even wait for the response. Just be like, I'll check back later or tell me when it's done. And then your background system could have been going and have some mechanism to inform this bulk report is done.
Right,
Kind of
yeah,
decouple that.
that's a good idea. Just save 8 of those shipments that week, and then your request is just for those 8 shipments that week that you're trying to follow.
Yep.
So,
Yeah, that's a good strategy to take if you have a lot of consumers of an API or something, and you got a lot of long tail compute that might need to happen. Maybe it's calling a step function, and you've got a large workflow to find the data,
yeah,
go through the data,
that's where I really want.
get all that data together from multiple sources.
Functions are a little intimidating to me right now. I don't know why. I mean, I feel like I have the knowledge, but I have to. There's some stuff that I can change from that
Mhm.
kind of spread out lambdas into like one big workload, but yeah, I have to take that plunge at some point.
Yeah. Well, next week I am doing a lab for us. We're going to be doing an interactive workshop. It's going to be online. And if you'd like, I can work on finding some content that helps us walk through step functions to kind of de-risk and demystify it. How would that be?
Yeah, like
Yeah.
that.
Anybody else in favor of seeing step functions next week? Yeah. Okay. I had a short list of ideas. I'll check what came back in the survey results as well, but I'll look for that. It probably wouldn't take us very long to go through a lot of it, but we can probably see a lot of the use cases and get hands-on with it. Maybe not have to, as you said, be going in the dark on that one.
Yeah, and I know that it's gotten to where I think you can almost drag and drop things. It's just kind of like controlling the state and the response of this is done, so now you can do this,
Mhm.
and you can have even like a workflow within the main stack function. So
Yeah. Yeah.
it can get pretty rowdy.
Do you have a language that you prefer? That
Python.
Python? So in Python, you got your for loops, you've got all sorts of things in there, and you've got your try catches to catch exceptions. And you can put things together. You can even make things happen in parallel inside of Python as well. A lot of those same concepts you can do in step functions. You can, you've got a map function inside of Python. So a lot of those concepts actually translate over nicely. They took a lot of those constructs over, kind of put that into a into a serverless service where you can orchestrate all of that, kind of lift that away. It's not defined in any specific language, and you can use things like the cloud development kit to define it, but then you end up not having to manage running that in like a Lambda or something. So yeah, I'll look through, I'll try to piece together something and try to draw some parallels there for you.
Cool.
Yeah.
So the steps a new application there?
Step functions? I can look up offhand when it officially came out, but I think in general, I think it's over 5 years old now, if I recall correctly. But it started pretty bare bones, pretty basic. But over time, it got a lot of what we were just talking about. You can you can orchestrate a lot of what we showed. You can take an API call to initiate this visual workflow. The big takeaway for a business person is, oh, I can visualize what my developers are implementing, and this pretty diagram gives you a directed acyclical graph, an image for you to show the state transitions, lights up red and green and all kinds of pretty colors. It's almost Christmas time. I might build a Christmas tree in step functions. That could be my advent of code right there. A day at a time, one thing, give me some red and green on a step function. But yeah, it gives you all of these capabilities, and something they just dropped, I think this was 2 years ago now. Step functions originally could only integrate with a handful of services. It now can make service calls to pretty much the whole AWS catalog of services. And so any AWS SDK call you can make inside of step functions. So yeah, my first introduction to it, I had a file-based workflow that was basically end of day tickets, receipts, basically. And that was processed. It was like and on a peak day, it was like 10 gigs in size. And they would load that all up into a server in memory, which would inevitably crash on peak days because who has 10 gigs on a older system in memory? Good luck with that. You have to manually change the XML file, chunk it up into like 1 gig chunks just to get it to hop along. But we ended up using step functions to map through that, iterate, and queue up each section. We were basically finding the places for all of the important data, and then having another function come back, find that piece, and process it. Took like what a process that would take a day. Well, it was mostly like an evening, a few hours. We got that down to like a minute for a full peak season. So it does a lot, and since then it's improved a lot. You can do a lot of simultaneous requests to various files and process them independently. So yeah, we'll start taking a deep dive. It sounds like there's a lot of piqued interest in step functions.
I meant to ask you, I just have this question. Is there going to be a certification at some point for serverless architecture? I know there's certifications like solution architect and all this stuff. I think they'll work, or is that too?
I work for training and certification. I'll disclose that first.
Yeah.
So the best I can tell you is that knowledge readiness path and that learning badge is what you should look for. There are showcases of serverless on a lot of the exams, because serverless itself isn't something that you should really specialize in as its own thing. You still have solution architecture, you still have DevOps, it just happens to be on serverless components. And so you're going to see a lot of those aspects on those different exams still get a lot of additional representation from server full workloads and serverless workloads. But if you're really looking to kind of dive deep in serverless, sounds like you may have already taken that major step towards the learning badge. But yeah, you can keep going. You can you'll find more of those. Who here has an AWS certification, has taken and passed one? Awesome. All right. Well, if you ever have questions about that, I've presented on it before, happy to talk about it. But you'll see a lot of this as you continue taking those strides. You learn the vernacular in cloud practitioner, you get hands-on in the developer associate, and then DevOps, you can professional, you automate some of this. Solution architect associate, you play some digital Legos with some of those moving pieces, and then solution architect professional, you start getting really deep into the nuances of going deep into that. And you'll see serverless show up on each one of those. Yeah. Bill.
Now, I hate asking questions because, but I'm curious, like, how do customers address the management or the support from a help desk perspective? For example, managing a serverless environment versus managing a single server that has a single app that everybody knows where to go to work on. How does the support change in serverless environment?
Yeah, education is a big factor in adoption in a lot of places. And what you're saying is crucial, because part of the reason sometimes we as engineers can't act on an idea is because we realize it's not just solving the problem, it's the maintenance of that problem and all of the education that has to come along with it. There's a lot to displace there. Education, I think that's a large one, but still you end up finding patterns like having specialized API endpoints for them to write a customer service application to view, things that were moved in a queue into a dead letter queue to be able to re-queue that. And so you end up writing those internal interfaces that inevitably exist in some cases. You could write those wrappers and make it to where they don't need to know. And then you can build those hooks. And then you can lean further into educating those individuals, get them hands-on, get them aware to where they can go. Here's the API, here's the dashboard, here's the queue, here's the dead letter queue. You can click this button and automatically re-queues it, and then it just goes, and you can watch and see it go through. But then that gets to points, opportunities of tool selection. If you want something visual, step functions. I'm not paid by step functions, but for this reason, I love it. I actually, as a customer, I joined about a year ago, AWS, a year and a half ago. But my adoption scenario for step functions was The customer service people could visually see where it was in the workflow. And for that reason, they were like, I don't know what it means. I don't know what it is, but I can see it. I like it. And it was more than what they had before. They didn't have to jump on a server, check if a service was running, do all the command line tools and so on. But we were, you're able to implement those internal interfaces that mask those details away.
Thanks.
Yeah. All right.
I guess like along those lines, do you remember this article from this past summer about how the AWS refactored, AWS Prime Video refactored from microservices to more monolithic application and let them scale sort of more and reduce the costs? Like, is it always a good idea to start with microservices or not? I guess that's what my question is.
Yeah, so there are two sides of that. There's premature optimization, and then there's designing for your business problem and just playing to where the natural seams are. I think we're getting close to time. You want me to make this the last one?
Yeah, probably should.
Okay, so we'll make this the last one. We'll dig deep into it, but there is a balancing act, and it really depends on your business needs, your budget, and your customer problems. At the end of the day, your customer doesn't care if it's a microservice or a monolith. They care that it loads quick, it works, and it's reliable. So as you're making those trade-off decisions, it can kind of lead you to make those technical decisions as well. In that scenario, I can't recall all of the details, but I do believe it may have had to do with they were over provisioned in a few areas, and then there was tail latency or a lot of latency because of a lot of the network calls involved in some of those cases. And so, by observing the full scenario, consider the full, sandbox that you're playing in, observe all of the influencing factors and making decisions to consolidate and optimize. Earlier, we made a decision to, instead of managing S3 and CloudFront directly, we decided to lean on Amplify Console to manage that for us. We could know enough that was happening behind the scenes, but it masked that detail from us. There are opportunities to pick a tool to take those details away from your management at some trade-off in some cases. So I would say a lot of that comes down to your functional and non-functional requirements.